Hello, a NASA space probe has made history by flying closer to the sun than any other spacecraft. The probe plunged into the sun's outer atmosphere on Christmas Eve. Scientists received a signal from the Parker Solar Probe after it had been out of communication for several days during its burning hot flyby. Well, the spacecraft came within 6.1 million kilometres of the sun's surface, facing temperatures of around 1,000 degrees Celsius. Scientists say the mission will provide data that will help forecast space weather events that can affect life here on Earth. This report now from our science correspondent, Pallab Ghosh.
It seems like science fiction, sending an uncrewed spacecraft to the sun. NASA's Parker Solar Probe was designed to withstand its scorching heat. But could it? NASA has now confirmed that it has. The spacecraft sent back a beacon signal indicating that it survived the closest ever approach to the sun.
We have never had a human-made object so close to the sun. Also, we had to not melt. That's why the Parker has this heat shield that holds the instruments at room temperature and keeps the heat of the sun away. And these are just amazing feats. And so it's so amazing that we are so close and really getting to measure in detail this material up close.
Liftoff of the mighty Delta IV Heavy rocket.
There have been many missions to study the sun, but there's so much more we can learn, especially about the sun's shimmering atmosphere, which we can see from Earth during a total solar eclipse.
This new data from this very incredibly close approach of the sun, just touching the surface of that corona, is going to hopefully give us a lot more information about exactly what's going on in our beautiful, beautiful sun that heats up and gives us light.
Close up, the sun's magnetic field twists and lifts its explosive surface. It's hoped that the solar probe will shed light on the processes that make this happen and how this solar turbulence affects us on Earth. But they'll have to wait until the 1st of January before they see the initial data. Pallab Ghosh, BBC News.
Well, we heard in that report from the Astronomer Royal of Scotland, Professor Catherine Haymans. She's been telling me more about the news of that historic flyby.
It made its closest approach on Christmas Eve, but it was on the far side of the sun. So it took until this morning for it to come back around for the Earth to be able to communicate with it. And at 5 a.m. this morning, a radio station in Canberra, Australia, got the message that it was safe and sound, which is an absolute joy for us as astronomers, because this really is the finale of this mission. It's been up for the last 7 years, looping, doing an orbit between Venus and the sun. And each time it's gone past the sun, it's got closer and closer. And this is the first time it's reaching temperatures of about 1,000 degrees Celsius. And amazingly, it has survived. It was built to survive this, but it's worked. The electronics on board have not been fried by this journey. They've been protected by an outer shield. And it's been recording data about the magnetic field on the sun, the high energy particles that are there. It's been taking images, and it's also been looking at what's happening there. And the biggest question that there is, that we still want to find out the answers to, is why the atmosphere around the sun is so extremely hot. And that's what we're hoping this last finale of this mission is going to be able to tell us.
So this is a really important scientific mission, isn't it? It's looking for some really interesting and important answers to key scientific questions.
Yeah, absolutely. So on planet Earth, if you go up in an aeroplane and you fly higher and higher in our atmosphere, it gets colder and colder. But the opposite is true with the sun. There's a region around the sun, the atmosphere, that's called the corona. And it is a 1,000 times hotter than the surface of the sun. The sun is already incredibly hot. The surface of the sun is 5,500 degrees Celsius. But in the middle of this corona, we believe that it gets to up to 1 million or 2 million degrees Celsius. And we don't understand why, what's causing that to get so much hotter than the surface of the sun. The early results from the Parker Solar Probe suggested that it's to do with the magnetic field. It gets all turned and twisted up on the surface, which we see as sunspots, which create these big solar flares that we get to appreciate here on Earth as those gorgeous northern lights, the aurora that we've had a lot of this year. But there's a lot that we don't understand about how that all works, how that could be fueling this hot atmosphere around the sun. And this new data from this very incredibly close approach of the sun, just touching the surface of that corona, is going to hopefully give us a lot more information about exactly what's going on in our beautiful, beautiful sun that heats up and gives us light.